Hi guys, I'm going to be looking at the integral of e to the x cos x dx. So on this one, it's not really clear which one we should make which one we should choose as our dx. So you can choose any in this case, because remember, when we started with integration by parts, we said that you need to look for a polynomial, right? So if there is no polynomial in your integral, it's not a product of two functions of which one is a polynomial, then you can, if it's not arcsine, if it's not arccos or arctan or ln, those are other special cases. Then it's another special case where you need to choose any. So you can choose either cos x as your u, or you can choose e to the x as your u. You will still arrive to the same answer. But it's much easier to choose u as e to the x and maintain that throughout. So you need to choose your u. I recommend that you choose your u as e to the x. So if you are choosing u to be e to the x, you're going to say let u, so let u equals e to the x, meaning du over dx is going to be e to the x because it doesn't change. Then dv over dx is going to be what's remaining after we have chosen u. So what's remaining of our integral after choosing u is this cos x there. So dv dx is going to be cos x. V is going to be the antiderivative of this derivative. So we have the derivative of cosine of x. We need to integrate that to get v, which is the original function, right? We have this derivative, which is cosine of x. We need to integrate it to get the original function v. So finding the derivative, the antiderivative of this derivative gives us v. So the antiderivative of cosine of x is what? It's sine x, right? Remember, with differentiation, we would say the derivative of cosine is minus sine, but with integration, it's the opposite. So it's the exact opposite. We're going to get that integral as sine of x. So we're going to then apply our formula for integration by parts. Remember, it says the integral. Let me just write it on the side. So we have the integral of u dv over dx equals uv minus the integral of v du. So this is v du over dx, right? So it can also be written as the integral of u dv equals uv minus the integral of v du without the dx's. So you're going to have something like this. And then you're going to say your integral of u dv dx is going to be the integral of e to the x, that's your u. Your dv dx is cos x, so you're going to put cos x, then dx. So you're going to have something like this. Then you are going to say this here is equal to it's equal to uv. uv is e to the x sine of x minus, that's the negative from our formula for integration by parts. So that's going to give us the integral of v, which is this one, du dx, which is e to the x. So we're going to get e to the x sine x with respect to x. That's our v du dx over, v du dx, right? So we also need to solve that integral because we have an integral in our solution. So that's an integral in our solution. So what we are going to do is we are going to solve that integral and we'll put its result because we don't want to have an integral in our solution. We're going to solve it, and that means we are removing it from this bracket, we are putting its result, right? So we remove this integral, we put its result. So we need to first find its result. So we're going to say let u equals e to the x du over dx. As I said from the beginning, maintain your u to be e to the x so that you don't get confused. So you're going to have du dx equals e to the x. dv dx becomes what we didn't pick as our u. So automatically it becomes dv dx. So we have dv dx equals sine x. V becomes minus cos of x, right? Now we apply integration by parts for the second time. So we are going to say the integral of e to the x. So this part we write it as it is, right? The integral of e to the x cos x, nothing has changed there. We only touched there. So here we just write it as it is. We don't need to change anything because we haven't done anything there. So we're going to have that negative, then we have our bracket for that integral. Now we're going to say uv, it's minus e to the x cos x, then minus the integral of v. V is this one here, right? So it's minus cos x, du dx is e to the x. So we have minus e to the x cos x. But this negative sign, here we're going to have the x, right? But this negative sign and this negative sign will form a plus. That happens if we factor out this negative as a minus one, because we can factor out constants from the integral sign. We know that constants can be factored out. We are allowed to do that. So that's going to be a positive sign. So we can then expand this bracket. We can then expand. What we have done here is we have removed that integral. We have put its result, which is that we got it from this, right? So we just applied the formula for integration by parts. So what we're going to then do is expand that bracket. If we expand, we're going to get the integral of e to the x cos x dx equals e to the x sine x. Here, if you multiply there, you're going to have a plus, because you have a negative and a negative. That's going to give you e to the x cos x. Then this negative and that positive, you multiply there, you get a negative integral of e to the x cos x dx. Now, if you look at this here, and you look at this one, if this is a cow, that's a cow as well, right? We don't care what it is. It's an integral, of course, but we can add anything. We can add anything like that. You can add sweets, for example. They don't need to be numbers. If you have one sweet and another sweet, you have two sweets, right? If you have one integral and another similar integral, you can't add, for example, a cow and a sweet, right? Because that's going to be a sweet plus a cow. That's going to be x plus y. You can't add x and y if they are not the same, right? So if this is a cow, that's a cow, you can have two cows, right? So this here is a negative sign. So if you take it to the other side of the equal sign, that's going to be a cow plus a cow, because this one here becomes positive upon crossing the equal sign. So we're going to have two cows, right? We're going to have two cows. So I'm going to say here we have two of these integrals, e to the x cos x dx. We have two such integrals. Then it means it's no longer on this side. We have put it on this side, and we have put it 2 here because we now have two integrals of e to the x cos x dx. So on this side, we're going to have e to the x sine x plus e to the x cos x, right? We're going to have something like this here. Now, we will say, okay, this solution is not complete because remember, we were not asked for two integrals. We were asked for the integral of e to the x cos x dx, not two of these integrals. So what do we need to do with this 2? We need to divide both sides by 2. So if we divide both sides by 2, we're going to have something like this. So it's going to be the integral of e to the x cos x dx equals e to the x sine x plus e to the x cos x. We can factor out this 2 there and put it as a 1/2 outside the bracket. And then we can put our constant of integration c. So that's our complete solution.